Hello guys, so let's start today's session and my name is Naran Singh Dangi and welcome to the Deep Learning by Naran Singh Dangi coding blog. So let's start about today's discussion and today basically I am going to explain you the project called potato disease classification. So basically in this project we have a sample of some potato images where we have to classify like this image is have disease or not and this image have disease or not. So if you are doing a project in if you want to do a project in agriculture domain, then this is the best project you can do it. So let's start our discussion like how to get this data and how to build a model to classify these images have a disease or not. So let's start it. So basically this is the file code. Wait, I will import it in this file. So this will looks like good. Wait 2 minutes guys. To disease. Yeah, wait 1 minute guys. It is loading now. So this is our file that we want to learn. Okay. So to build a like potato disease classification model, firstly we have to import some library. So basically we are using a library called TensorFlow to build this model. TensorFlow, if you know a TensorFlow, then this is easy for you to understand this project. And NumPy Panda is basically same like to do some calculation. So basically for this project, this is our directory like plant blaze. I have a data set called plant blaze. So firstly we have to upload this data set and I will paste it the data set link in the description, you can find it out. And let's start our discussion like how to build this model. So firstly we have to load this data set from our directory. So here I have defined some parameter like this is our data set, ds known as data set here. So we will call this function. Yeah, here we have defined a data set and we are calling this function like tf dot. Here we can also call it and get data set parameters by TensorFlow also call it. So that's how this will work. Here basically we have load our data set by using this library. If you define like if we firstly we have to download the data set and the data set have a directly the first directory will have a good images which will not be infected, and the second directory will have a infected images. But we have a three directory and like the first one is defected, second one is maybe defected like probability of like may this may be defected if you not use up parasites in your pesticide like some pesticide is there to remove this infection from this plant. So if you may be infected, so maybe some probability, but the third category may be the highly infected images like 100% or not maybe 92. If the percentage is greater than 90%, we can say that it is infected. So that we have a three classes of potato images, and now we have to load this data set. So by using this function basically we have defined a data set directory, and data set directory is basically this known as. And here after seed we have defined a seed equal to 1 2 3. So seed, if we define this will load data set every time the same. If we define not define a seed equal to this, then the seed will be random. So every time this will be randomly shuffled images will become. So that's why we have defined a seed. So that every time if we run this file, the images will be same like numbering. Image size we have defined default image size, and default image size basically here we can see that image size of tuple, and this is 256 by 256 image size. And the third one is batch size. Also batch size is basically 32, maybe the norm. Every time basically we have defined a batch size of 32 because this may be known as a very good batch size. Or basically if you change a batch size you can change it, or so if you want to change you can define it as a 2 raised to the power of n a batch size. So that's how we will load this data set, and after loading the data set we have defined pass the data set to this function. So this data set will basically give us a training data set and validation and test data set. So by passing this, basically we have said this we want a train data set of 80% and validation of 10% and testing of a 10%. That's how we will define shuffle equal to true. So we basically we want to do a shuffling of this data set, like randomly shuffle data set will become, and shuffle size basically we known as we have given as a 10,000. So now, so train test and validation split we have a assert equal to 100%, basically we can say that. And now we have defined a train size equal to data size, like train split 0.8 into data size basically we have a length of the data set we have. So now this will train size will become, and validation automatically, and testing basically everything will be automatically will came. And here we have defined take the first like 80% and 10% as a validation and 10% as a testing data set, and this will return all of your images. Now we can see that this function defines like uh, three images like early bright, late bright, and healthy. The third class basically known as healthy images. Here you can see that. Is there any healthy image is there? Early related healthy image is not showing, but you can see that healthy means no infection, and late bright means, and early bright means there may be chance of infection, and late bright means it is infected already. So early bright images looks like this, and late which looks like this, and this you can see that we have a data set like this. Now we can see that every like batch we have, in every batch we have 32 images, and every image will have 256 of 3 pixels, like 256 to 56 dimension. And if we have a one, that means is the black and white image, but if we have a 3, so that means we have a RGB images. That's how it will work. And now we have to define a train data set, validation, and testing data set. So we have load this as a cache. So basically in cache if we load this will be train our data set very very fast. So like every time we have to do not to load this data set, it will be in cache. So if we train, it will be very very fast in buffer size. Now building this model. So how to build this model? Now let's see. So create a layer for resizing and normalization. So basically firstly, if you train your model without this scaling, then your model performance is not good. So what we have to do it, we have to rescale it from 0 to 1, or we can you can also rescale from -1 to 1. So the best way is to rescale the images is to 0 to 1. So that's why we have to multiply, like divided by all of the pixel from 255. So that's how every images will be converted into a pixel to 0 to 1. So this will be a good for to training. Or if it will take some time if we don't divide to 55, and the accuracy is not also good. So that's why we have to define like dividing by 255. This will give have a two advantages. Like the first advantage is to it will give a good accuracy, and the second one is to basically it is the computation is very very fast because the number is from 0 to 1. So the computation is also very very fast. Now data augmentation. So for data augmentation, we have images of same size, like in a same manner. But at the time of testing, we don't know the user how the input will give. If they will take it like this, like rotating the image and vertical, and maybe this will take in a different angle. So that's why we have to like augment this by images. So by horizontal and vertical, we have to rotate these images. So for training also we have to rotate it. So at the time of testing, we don't have to face any problem. That's why we have to do a data augmentation. And now for this image size, we have already defined it. This is our image input size, and batch size already defined it, and channel dimension defined it as a -1, because at the time of training we have to pass a 4D dimension, so that our basically every image will be passed in a 4D dimension to train this model. Because at a time we will not pass a single image to train this model, we will pass bunch of images. That's why we have to define it like channel dimension of 4D. So now let's see our model input, like model architecture. If you understand all of, if you see my deep learning playlist, I think you will able to understand it. I have already explained like how to create a CNN model, and what is the meaning of convolution 2D, and like number of filters, what is the use of kernel size, activation function, input size, everything I have explained it. So now let's see how to create a model. So basically we know that for images we have a number of class, for basically we know that we have a number of classes equal to 3. So we have to apply last layers a number of classes, and this is our output layer. We have 3 layer and apply activation function as a softmax. Sigmoid, if we have 2 classes, then we have to apply a sigmoid activation function. But here we have a greater than number of, if the number of classes is greater than 2, then we have to apply the softmax activation function. So softmax activation function probability lies between 0 to 1. So this will also works very very well. And the like your gradient descent function known as Adam optimizer, here we are using our Adam optimizer. I think here we can see that, yeah, Adam optimizer, like most of the cases, like 99% we will use Adam optimizers. So to get a good accuracy or in a very fast manner, we have to apply Adam optimizer. And to gain, like we have if we have applied software activation function if the number of classes is greater than 2. That's it. So now let's see the input. So we have to firstly pass this resize and rescale, and data augmentation is also passed. So automatically this layer will apply to our images. And the third layer is basically convolution 2D. So firstly here we have to define like what is our input size of our image. So here we can see that our input size is basically, input shape is basically that size. Basically every time we will pass 32 images and 256 by 3 channels we will pass it for this input side. And we have applied a activation function as a ReLU. In between most of the cases, like 90%, we can use a ReLU activation function because it is very very fast. You can see that it is a curve like this. So if the, like, also the formula is called max of 0 comma x. So if the value is greater than 0, it will be, output will be 1 like x, and if the value is greater than, less than 0, it will be 0. So that why the calculation is very very fast. That's why we will apply activation function as a ReLU in between of the this function. And optimizer, basically we have to use Adam optimizer. And basically this is, firstly we will discuss about like optimizers, or we can, firstly we will discuss the model architecture. Let's, so all this is our input size of the image. We will pass this image, and for every image basically firstly we have a 3 number of features, or we can say a number of dimension of image. So and after this passing to the first layer, we will get a 32 number of features for every image. So basically this feature, what will happen, this will extract the information for every different criteria. Like suppose I am a human, if we pass train a human faces on a model, then this will every feature, like number of these are basically number of layers, or we can say a number of features of this, how many layers we want to extract it from this every image. So here we have defined 32. So if we define 32, each and every number of pixels, or we can say number of layers, will extract some information from these images. That's why we have to apply this number of layers. Here we can see that bit control shift is not working, tab, yeah. So number of I will not getting conv 2D convolution layer. If we see this input convolution 2D layer input, so filters, yeah, so this is known as number of filters, how many filters we have to apply it. So we have applied 32 filters for every image. Firstly, our image filter has a 3 shape. We can see RGB, but after applying this first layer, we will get a 32 number of different number of filters applied. So we will get 32 number of filters, and kernel size we have defined as a 3 cross 3. So here we are not applying a padding equal to same. If we apply padding equal to same, the image size will be same. But here we have applied kernel size equal to 3 cross 3 and padding not applied. So our like output image will be n minus f plus 1. So basically this is our 32 minus like 256 minus filter size is 3, so n minus f plus 1. So basically 3 minus 2, 2, so 254 cross image will be get. And after applying a max pooling by 2 cross 2, so we will have a image of now 254 number of filters like pixels in the by applying this max pooling layer. So basically max pooling will extract the max features in the images that we have. So now we will get a kernel like images of 255 divided by 2. So basically 124 maybe, yeah, 122, 250, yeah, 122 pixels of this image we will get it. No, not 250, 127 cross 32 in pixel number of filters we will get it. And each time we are applying this same activation function and relu this will applied max pooling. I think you already know it, convolution, max pooling, convolution, and after that we have to flatten this layer. So here we can see that firstly we will pass 32 images with this number of pixels like 256 with 3 number of filters, and after that basically we will get 32 images already there. By applying a convolution to delay, we will get 254 with 32 number of filters, and applying a max pooling on that we will get 127 cross 32 number of filter, and then we applied a 62 filter, and that's how it will work. And here we have applied a flatten layer. We have 2 cross 2 cross 64, so now we have applied a flatten layer. So flatten layer will get give us a 32 comma 256. And then we have applied a dense layer. So dense layer is basically nothing but a ANN, artificial neural network layer, which will looks like our human brains. And here we have defined that will get a 32 cross 3 output. 3 means basically our output, and 32 means we will pass 32 images and we want 32 output as a label as a 012, or 012 means basically late bright, early bright, or healthy images. That's how it will work. Now coming to the compiler. So basically we will applying optimizers, atom optimizers. I think you already know that atom optimizers is very best optimizer nowadays. So 99% we will use atom optimizer, and loss function we are applying as a sparse categorical cross entropy. We will can also apply a categorical cross entropy if we our output has a one hot encoding vector. But here we will not convert our output as a one hot encoding. We have output like 0 1 2. So we have to apply a sparse categorical cross entropy from logic equal to false, and applying a matrix equal to accuracy so that we can see the accuracy or like performance of our model. Now our time is to train this model. So we have applied model dot fit function, and apply after applying model dot fit function basically we will pass our training data set and define the batch size. Verbose equal to 1 means basically I want to see the performance of that model, like how this will working. We are seeing this now. If we apply verbose equal to 0, we can't able to see the performance. We will get directly get the output. And epochs, like how many epochs you want to train the model. Epochs basically means and how many number of times you want to give this data to this model. So like the first time we the model will not know like this is a this image is basically infected or not. But after now certain number, like we will every time say this is, suppose a small child is there and we say to him like this image is infected and this is early infected and this is little infected and this is healthy. Suppose they are not able to know that, but we will train every time like 10 to 20 times. If we say that to this model, this will be able to understand. That's how we will train it. So here we are training to 50 times to this model, and here we can see that we get accuracy of approx 98%. That's good accuracy. So let's calculate model accuracy. So we will get approx 98% on the testing data also. And that's how like create a quantized aware model, max pooling today. We will already know that annotated model. Yeah, that's it for today and evaluating the TF model. So now after that creating the model, we have to save it model. So to save this model, you can get write, write this code like f dot write and quantize TF write lab model. This will like save your model in the dot TF write format, and you will now predict it any, or you can deploy this model to the cloud like AWS, and you can call this from. So for this calling you have to create a API, so you can create a API in fast API. If you want this code, I will give you this code in the GitHub repository. You can find it out and you will get everything. So that's how this will work. And confidence, here you can see that like actual photo is laid bright and our model is also predicted laid bright with accuracy of 97% and 96. Here you can see that every images, here you can see that. That's how this will work. So confidence level also we can get it. Yeah. So firstly we have to create a classification model. After classification model, this will give some accuracy using here we can see that confidence np.max output, the class that they are giving output as a some probability basically. So the probability, if we find out using numpy, we can get at some accuracy like this. So if your accuracy is greater than some, you can define also a model like if the accuracy is greater than 80%, then it is correct model, otherwise it is a wrong model. That's how it will work. That's it for today guys. Or if you want the like create the flask API or fast API to call this model, comment it down. I will create also a video for that, how to create a API in Flask or Fast API to call this API, and also do a deployment if you want it. Thank you guys. Let's meet in the next lecture. Jai Hind, Jai Bharat. Please subscribe my channel also. You will get a good content like this. Every time I will be create a video like this to motivate everyone to create a how to create a machine learning model in a very simple way. You can also create this type of model. It's very simple basically. If you know the basics of deep learning and machine learning, the creation of this model is very simple. You can easily able to understand it under each and every concept. Thank you guys. Let's meet in the next lecture as soon as possible. Maybe I will create some different project in the next lecture, which will be every time a unique project. You will get enjoyed. जय हिंद, जय भारत गाइस. मिलते हैं नेक्स्ट लेक्चर में एज सून एज पॉसिबल. बाय बाय.